Today we will be covering Section B of Chapter 7, Rational Expressions. Section 5 is solving equations containing rational expressions. First note that an equation contains an equal sign and an expression does not. To solve equations containing rational expressions, you clear the fractions by multiplying both sides of the equation by the least common denominator of all the fractions. Then solve as in previous sections. Note this works for equations only, not simplifying rational expressions. For example, solve the following rational expression. 5 over 3x plus 1 equals 7 over 6. Your least common denominator is 6x, so you multiply all terms by the 6x. Here your 6x and your 3x cancels. 6 divided by 3 is 2. 2 times 5 is 10. The x's cancel. Here you have 1 times 6x, which is 6x, equals 7x. Here, because 6 divided by 6 is 1, leaving you with the x. And you multiply 7 times x. And here you solve for x. X is equal to 10. Substitute the 10 into your equation to check to see if it's true. Here's another example of solving rational equations. You multiply both sides by the least common denominator, which is the both of them, x minus 1 times x plus 1. So you multiply the first term by that, canceling the x minus 1, which leaves you the x plus 1, equals 2 times x minus 1, because here the x plus 1 cancels. So simplifying, distributing, and solving for x. X is equal to 3, and then check your answer by substituting 3 back into equation to see if your equation is true. And it is. Another example. Here you factor the denominator. 9 minus a squared. Factoring that's 3 plus a times 3 minus a. Therefore, that is your least common denominator. Multiplying all terms by your least common denominator cancels the denominators, so you're left with 12 for the first rational expression, plus 3 times 3 minus a, because the 3 plus a cancels, equals 2 times 3 plus a, because the 3 minus a cancels. Solving for a is equal to 3, and then checking your solution. 7.7, simplifying complex fractions. Complex fractions are rational expressions whose numerator, denominator, or both contain one or more rational expressions. There are two methods that can be used when simplifying complex fractions. Method number 1. Simplify the numerator and the denominator of the complex fraction so that each is a single fraction. Step 2. Perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. Step 3 is to simplify if possible. Example, x plus 2 all over x over 2 minus 2. Here you treat the numerator as a fraction. You find your least common denominator there, which is 2, so you multiply the 2 by 2 and the denominator by 2, which leaves you 4 divided by 2 plus x plus 2. Here your least common denominator is 2 also, so you do the same here, combining this numerator, combining the denominator. Here you have a division, so you flip the denominator, and here is your multiplication, and you solve using the rules of multiplication. Simplifying complex fractions using method 2. Step 1, multiply the numerator and the denominator of the complex fraction by the least common denominator of the fractions in both the numerator and the denominator. And step 2, simplify if possible. Here's an example. 1 over y squared plus 2 over 3 all over 1 over y minus 5 over 6. your least common denominator is 6y squared, so you multiply all terms by the 6y squared, leaving your final answer as 6 plus 4y squared over 6y minus 5y squared, and you leave that answer as is. And that completes Section B, Chapter 7.